So welcome everybody. Thank you for joining us today. We talked a little bit about setting up what was going to be an interesting set of discussions today. And we came up with, oh, it looks like someone wants to join. There we
Yeah,
go.
I'll take care of those.
Okay. We talked about what was interesting and what was a very common kind of gap or miss in some of these conversations, which is VPC communications and workload acceleration. So I promise I'm not going to go too deep into the weeds of networking. This is a little bit higher level than your packet level discussion, but hopefully we'll be able to talk about a few services and solutions here today that will open up some conversations and help you understand some different patterns or options to look at. So I know we did a little bit of a introduction here previously, kind of informal, but I'm going to be speaking today. I first joined AWS in 2013, and I've held several different roles in AWS. Today, I manage the team of solutions architects covering the Southeastern United States, and I focus on state and local government customers. So obviously based in Florida, my focus for myself personally is Florida and our state and local agencies, but also my team expands into the Southeastern United States. Prior to AWS, I've held technical roles such as startups such as allrecipes.com, enterprises such as Bright House Networks here in the area, and government agencies such as the Port of Seattle. So I've been able to get an experience across a wide breadth of different environments. Today, we're going to cover VPC Peering, Transit Gateway, the Transit VPC Solution, Amazon CloudFront, Global Accelerator, and Accelerated Site-to-Site VPN. Now, we don't have unlimited time, so I'm going to be staying relatively high level today. But all of these things are very easy to find more information on our documentation and our site. And I'm also always happy to share links and reference information as well. And if you are working with an AWS account team, they're always happy to get you this information as well. So let's do a real quick review here on just some foundational concepts before we dive into these. The first one being a region. AWS has the concept of a region. That's a physical location somewhere in the world where we cluster data centers. Each region has multiple availability zones, which we'll talk about in a moment. And unlike other cloud providers, we define a region as always having multiple availability zones with one or two exceptions that were built out based on special asks. Now, an availability zone is one or more discrete data centers with redundant power, networking, connectivity within a region. And within these availability zones, right, you think about these are all connected with high bandwidth, low latency networking. It's all redundant, dedicated metro fiber connecting them. Also, all traffic between availability zones is encrypted. We also have the concept of a virtual private cloud or a VPC. This enables you to carve out your own isolated area of your environment in AWS. You might kind of think of this and begin to use it as kind of an extension of your data center, and that's really the intent. This allows you to have that isolation and security that you need. All right, so when we first started out with VPCs, our conversations with our customers was more about, why do you want a VPC? I remember, I was here during the time when we didn't even have VPCs. I remember when they were first launched, and we had a lot of conversations with customers about, why do you want that VPC? What is it good for? What do I get out of it? And most customers started with one VPC. Things have changed. More commonly today, we have conversations about, how do I build this? How do I go to a multi-VPC, multi-region design? How do I manage that? How do my applications communicate across that? So today we're going to dive into some services and solutions that are going to help you decide, how could you build this? How do you allow your applications or environments to communicate? And how do you manage that well? Also, similarly related, how do you focus on your end user experience, the performance of your workloads running in these different regions? So let's start with VPC peering. By default, AWS provides network isolation between VPCs. Resources running in VPC A here have no connectivity to resources running in VPC C as an example. VPC peering, this is a network connection between two VPCs, and it enables you to route traffic between them using the private addresses IPv4 or IPv6. You can create a VPC peering connection between your VPCs or with a VPC in another account, and you can also peer VPCs in different regions. This is called inter-region VPC peering connections. One key note for VPC peering, it does not support transitive routing, meaning you can't route traffic from one VPC through an intermediary VPC and finally to its destination VPC. And in this diagram, for example, it'd be like sending traffic from VPC B through VPC A, ending up in VPC C. You just can't do that with peering. If you want to enable routing of traffic between all of your VPCs, you must create a unique peering connection between all of them, meaning a full mesh environment. So just to kind of summarize VPC peering, things that you need to remember: you cannot have multiple peers between the same pair of VPCs. Traditionally, you might think of that as an HA link between two different VPCs, but that's not how it works. AWS has built-in redundancy, so you don't have to try and recreate that. You can reference security groups between the different VPCs in the same region. You can enable DNS hostname resolution. You can peer for IPv4 or IPv6, but keep in mind, you cannot have overlapping IP ranges. You cannot have multiple peers between the same pair of VPCs, and you cannot use jumbo frames using VPC peering. So these are the key things to remember as you're building this out.
Hey, David, I should have asked you, are you okay if people just unmute and ask a question? Do you want them to do that with the chat window? You want to save those questions to the end?
No, please go ahead and ask away. If there are questions, let's make it a conversation.
Okay, terrific. Thank you.
So let's move on to Transit Gateway. Transit Gateway connects VPCs and on-premise networks through a central hub. This simplifies your network. It puts a better management concept or a governance overlook as compared to peering relationships. It's acting as that cloud router, and you only have to add each new connection once. As you expand globally or even just across the US, inter-region peering can connect through transit gateways, and your data is automatically encrypted and won't travel over the public internet. Now, Transit Gateway gives you easier connectivity because it is that central cloud router, better visibility and control because now you have that single pane of glass to understand your networking environment, and better security because your traffic between your VPCs within AWS will remain on the AWS private network. If you're connecting through Direct Connect, will run over your private fiber, connecting to Transit Gateway. So it allows you to create this global network that spans VPCs, regions, and your on-premise environment. While VPC peering solved communications between different VPCs, it's a better use case for smaller or simpler environments. There's a point where managing that complete mesh network becomes burdensome and just too much to do. Trying to track and manage and then monitor all of these peering connections becomes a very challenging task, not to mention that it grows in complexity very quickly. So just using VPC peering, which is what you're looking at here, every time you add a VPC, you have to add that peering connection to all of the other VPCs in your environment. Transit Gateway changes this. Transit Gateway is a service, and it gives you that central hub. And as you grow the number of VPCs or other workloads, you only need to add it once into your Transit Gateway. So you only have to create and manage a single connection from the central gateway into each VPC or your on-premise data center or a remote office. And now you have a central networking hub to manage traffic routing across your entire environment. When you do attach your VPC to your transit gateway, you do have to designate within your VPC, where do you want to attach this? And which subnets will hold that attachment? How you attach your transit gateway into your VPC can affect your routing options, and best practice states you should have dedicated small subnets in each availability zone to host these attachments. And remember that you can create subnets as small as a /28, so you don't have to throw away a ton of IP space to do this. Some key points about the attachments. A transit gateway attachment can be both a source and a destination of packets, right? You want to remember that when you're thinking about your routing rules. And you can attach different types of resources to your transit gateway. One or more VPCs, one or more VPN connections, one or more direct connect gateways, also other transit gateways so that you can peer across regions. So you have a lot of different options in how you shape your environment. So now let's move on to what we call a solution called a transit VPC. And this one's a little bit different. This is not an AWS service. It's a solution that you can deploy in AWS. And I'll talk about some of the key differences there. Transit VPCs can solve some of the same shortcomings over VPC peering that transit gateway solves, but there's a key difference, right? You still have that central hub. You still only have to manage that single connection to each VPC, and transitive routing is enabled and supported just like with transit gateway, right? These are problems or challenges that we're solving as compared to VPC peering. However, the transit VPC solution will allow you to use third-party vendor software running on EC2 instances in your transit VPC, where you can leverage advanced security services, whether it's layer 7 firewall, IPS, IDS, packet inspection, etc. And if you're using these same solutions on premise, you may want to continue to leverage those solutions in the cloud. And this is where transit VPC comes along. Now, it's a solution. So transit VPC solution does bring its own challenges as compared to transit gateway, which is a native service. So the transit VPC solution solves some of the same problems, but because you are running this, right? This is a solution that you're going to set up a VPC, you're going to deploy your EC2 instances running your third-party software. What this means is that you do have higher costs. Transit VPC solution will generally be more expensive as compared to transit gateway because you're running the virtual appliances, the EC2 instances. You're also worrying about licensing of the software. You do have limited throughput, so up to 1.25 gigabits per second per VPN tunnel, and additional configuration and management overhead, right? You now have to manage the availability and redundancy of these instances. That's not to say it's a bad idea to run a transit VPC. It just means that you should make an informed decision. So again, just to reinforce, this is a solution, not a service. You're not going to find this in the management console. A transit VPC is a pattern that you can deploy. So transit gateway is fully managed, monitored, and operated by AWS. Transit VPC, you are deploying this. And something that you have to worry about as you deploy this, right? We're going to talk here in a moment about throughput and performance. You have full control over that. Right, transit VPC, you need to make sure you're sizing your appliances, your EC2 instances, which might be running Cisco, Palo Alto, Fortinet, or others. You need to make sure that you're sizing these appropriately. Step through here. Here we are, transitive routing. Again, transit VPC supports transitive routing just like transit gateway because there is that handoff of traffic So that traffic is moving from one VPC to an EC2 instance, and from that EC2 instance on to another VPC. So because of that design, it is capable of transitive routing, just like transit gateway. So there are other considerations, like I mentioned, such as performance. With transit gateway, your maximum bandwidth for a VPC or direct connect attachment, again, this is for transit gateway, is 50 gigs. With transit VPC, because the traffic is running through your EC2 instances, your bandwidth is limited by the instance type and size that you choose. So for example, if you select an M5 or C5 instance type, your bandwidth could be limited to 10 to 25 gigs per second. Now, there's a few things to remember there. That's how much bandwidth your instance can handle, but your VPN tunnel is going to be limited to 1.25 gigs per VPN tunnel. Also, bear in mind, as you size up your instances running your third-party software, that's also going to impact your licensing. So some third-party VPN solutions or security solutions base their licensing costs on the size or number of cores that you're running. So keep that in mind as well. So you might be asking, right, you've heard me kind of talk about the advantages and disadvantages. Why would you want to run a transit VPC? There are actually some great use cases for this. You're already using a specific product or solution for your network security or routing solution, and you want to continue to use that. That's where a transit VPC is a great fit. Or if you know you're going to be moving to transit gateway in the future, but for now you kind of need to hit that easy button and expand into the cloud using something you're already used to, transit VPC is a great solution for that. Honestly, if you look at some of these other options here for visibility and monitoring, VPC networking, or other advanced security
I told you
services,
Rajiv gave an interview to BBC today.
I'm sorry, what was that?
But that was regarding earthquake. So yeah, like 6 years ago. And so they had.
I'm sorry, was there a question?
I muted him. I think that was unrelated to the presentation.
Got it. Okay. So, I mean, if you look at some of these other options here, as comparing transit gateway to transit VPC, transit gateway actually does make a lot of these other features easier, especially with some of these newer options that have been launched in AWS, such as traffic mirroring, security hub, guard duty. Transit gateway makes a lot of these other advanced features much easier and typically lower cost. Also, you won't have to worry about the operational burden, such as monitoring, failover, or patching. Again, not that transit VPC is a bad thing. It just needs to be carefully thought out. There are some really good use cases for it. Make sure it is a good use case for you. So let's
David, before you go to CloudFront, do you mind if I make an observation about transit gateway?
Please.
We've seen a lot of customers, they use the transit gateway from their direct connect, and they route all their, let's say, hybrid cloud, transactional data volumes across that. You're being charged, obviously, for the data flowing through the transit gateway. What I've seen customers all of a sudden get shocked at is you start using that for your data replication needs. And then all of a sudden it's like, wow, I'm paying hourly. I thought data ingress was free. It's like, well, it's free unless you shuttle that through a transit gateway. So we've always tried to tell customers, hey, transit gateway is great, but if you're shoveling high volumes of data from on-prem into AWS, you might want to have some custom application routing around your transit gateway just from a cost savings perspective.
It's a great point because it does add those additional costs that maybe you wouldn't have otherwise had.
Yep.
Yep. All right, so moving on to CloudFront. CloudFront is our fast content delivery network, or CDN service, and it securely delivers data, videos, applications, and APIs, something that a lot of customers don't realize, globally with low latency and high transfer speeds. So it includes field level encryption, HTTPS or TLS support. It's already integrated with AWS Shield, AWS Web Application Firewall, and Route 53. So you can add protection all the way to the edge. And all of these services are running at the edge locations. What this means is you can provide security and protection and block bad actors at the edge before it ever gets anywhere near your actual workload. CloudFront will work seamlessly with any origin, such as an S3 bucket, an EC2 instance, a load balancer, or any custom web origin. Maybe you're running something on-prem. As long as it's publicly reachable via HTTP or HTTPS, that works great as a CloudFront origin. So why would you use CloudFront? Again, it's that global scaled network. CloudFront has over 230 points of presence, or POPs, that are interconnected on AWS backbones. The AWS backbone is a private network. It's fully redundant. It's global, parallel 100 gig metro fiber, transoceanic cables across Atlantic, Pacific, and Indian Oceans, as well as Mediterranean, Red Sea, and South China Seas. Again, just a global scale. And I mentioned already that CloudFront will allow you to bring security out to the edge. And this is so you can start looking at how do you block DDoS attacks at the edge? How do you block geo restrictions for your content if necessary? How do you implement firewall rules, for example, common CVEs or OWASP top 10, all the way out at the edge? And also, CloudFront is included with our compliance packages such as PCI DSS, ISO IEC, SOC 1, 2, and 3, FedRAMP Moderate, HIPAA, and more. With edge compute features, CloudFront can also bring Lambda functions out to the edge. This means you can run that code at your edge locations. And this is really interesting for folks like us here in Florida. Right, our closest region is Virginia, maybe Ohio, depending on what you want to do. But how could you bring some of your functionality into Florida? Right, we have POP locations in Miami and in Jacksonville. So how could you maybe bring some of that edge computing all the way closer to your end users, maybe here in Florida? You can do that with CloudFront. So you can deliver unique content based on visitor attributes, generate custom responses, run A/B testing all the way out at the edge using Lambda at the edge with CloudFront. Also, Amazon CloudFront is very cost effective. There's no transfer fees for origin fetches from AWS. So if CloudFront is using an origin that's running in AWS, there aren't any charges for fetching that content, only when it has to fetch it from on-prem and it's going out to the internet to reach it. Also, you can use AWS Certificate Manager, or ACM, for free TLS certificates on your content running at CloudFront. So there's a lot of ways that you can bring your costs down and increase your security and your performance by using CloudFront. So let's go ahead and walk through this diagram. In this diagram, you see the end users of your applications on the left, and they're using the URL of your application just as they always would. For example, and we have two examples here in this diagram, cloudapp.mydomain.com and legacyapp.mydomain.com. Both of these are DNS records. They're CNAMEs that are pointing to your CloudFront distribution. Now, within one distribution, you can configure multiple origins and handle routing based on different rules or patterns. So in this example, if I have a request coming in for Cloud App, I'm going to route that to my cloud-based origin. And if I have a request coming in for Legacy App, I'm going to route that to my on-prem origin. But again, you can route those using different rules or patterns, and this is how you leverage CloudFront. One thing I do want to talk about with CloudFront is that it is a pull-based cache, not a push-based cache. What that means is you don't upload your content into CloudFront, right? And it doesn't proactively go fetch your content. When a user requests an object, At that particular edge location, CloudFront will look and see, do I have this already cached? If so, it will serve that content. If not, it will reach back to the origin, fetch the content, cache it, and then serve it. So just so everyone understands, because there are different types of CDNs. And that's one of the ways that we keep costs very low. Now, as traffic increases to your application, as you see here, CloudFront will serve that traffic from its cache, assuming it has a valid copy of that object. And this means that those additional requests are not reaching your origin. Your origins don't have to scale up to meet that traffic during peak periods. Rather, CloudFront is doing that for you. All right, so let's move on to Global Accelerator. Now, Global Accelerator, I have found, is something that a lot of customers haven't had a lot of exposure to. It's a networking service that sends your users' traffic through the AWS global network. And this improves your user performance by up to 60%, we found. When the internet is congested, it will automatically route to reduce packet loss, jitter, and latency. So let's look and see how this actually works. Global Accelerator provides you with static IP addresses that serve as fixed entry points to your applications hosted in one or more of the AWS regions. These IP addresses are anycast from our edge locations. This means that they're announced from multiple edge locations at the same time, and that enables traffic to ingress onto the AWS network as close to your end users as possible. You can associate these addresses to AWS resources such as application load balancers, network load balancers, EC2 instances, or elastic IP addresses. Now, normally a TCP connection is established with a three-way handshake between the client and the endpoint running your application. With Global Accelerator, we do TCP termination at the edge. And what that means is that the AWS Global Accelerator reduces that initial setup time by establishing a TCP connection between the client and the AWS edge location closest to the client. And almost concurrently, a second TCP connection is made between the edge location and your origin, your application endpoint. That really speeds up that initial handshake and that connection. Kind of walk through.
David, I'll just comment that I think the Global Accelerator is one of the best kept secrets, because we talk to a lot of companies that have SaaS-based applications hosted on AWS. And when you pose that question, they're like, what is that? How does that work? So great information from you.
Global Accelerator is going to use the AWS network to route TCP and UDP traffic to a healthy application endpoint. If there's a failure, Global Accelerator will instantly fail over to the next best endpoint. So this is also built in, right? If you are running in multiple regions and one of those regions is having an issue, those users who are close to that region don't have an outage. They're simply routed to the next best region. And that's just built into the service. Now, related to this, let's talk about accelerated site-to-site VPN. I'm sure everybody here has heard of AWS Site-to-Site VPN. It's been around for a long time, but there is actually a way to turn on acceleration. And again, for those of us here in Florida, this can become really important. When you connect an on-premise location to the cloud, accelerated site-to-site VPN will route your VPN traffic to the closest AWS edge location. Accelerated VPN will improve the performance of your site-to-site VPN by reducing the distance over which data is being shared on the internet and instead leveraging the AWS global network. So again, we're taking that traffic routing, we're taking it off the regular internet, even over an encrypted tunnel, and instead we're moving it over to the AWS network. So let's take a closer look at how this works. Let's kind of plug all this in. The top portion of the slide represents your typical internet-based VPN path. You're going to traverse multiple networks through the internet before finally reaching AWS. Your data is protected because it's encrypted, but there are multiple hops on independent networks along the way. Now, I don't know about any of you, but I know I can share some horror stories where some router in the middle of the internet does not perform to expectations, or all of a sudden is spitting out errors, and you have a near unresolvable network performance issue until that router operator decides to fix it. The key point here is that taking the typical approach entirely over the internet can provide some unpredictable results, and you're going to suffer from all the typical latency and jitter that you see traveling over the internet. The bottom half of the slide represents the accelerated site-to-site VPN. Here, the path that your traffic takes is to the closest edge location to your site. Then that traffic rides the AWS backbone all the way to the VPN gateway running in your AWS region. So let's talk about this with a real world example. If you ran over the internet from Tampa, you would cross over the internet the rest of Florida, Georgia, South Carolina, North Carolina, and finally Virginia to reach US East 1. That's all of those hops, right? And you're hitting different routers along the way. If instead you chose to use accelerated site-to-site VPN, your traffic would start out at Tampa and either go to Miami or Jacksonville, whichever one it decided was closer. And from there, it would ride the AWS fiber all the way to your VPC. That's the difference. So it eliminates a lot of extra hops. It gives you private fiber, low latency, low jitter performance. Any questions on that?
I just wanted to say that I think it's pretty cool that you can do internal load balancers with the global accelerator as well and reduce your attack surface. So I like that feature a lot.
Absolutely. Well, this is the end of the presentation. I know we've covered a lot of different services fairly quickly, but I do want to open it up to any questions. What can we answer for everybody?
I'll make a comment while people are thinking about their questions.
Sure.
We see a lot of customers saying, why would I want CloudFront? We're using Akamai today, et cetera, for CDN. We're like, just as long as you know you're paying data egress from AWS, you're paying for your Akamai services, they're probably charging you for data egress. So as long as you make that decision based on looking at the financials and the data transfer costs, more power to you. But it's amazing how many people really don't look at data transfer costs. They're looking at compute costs, storage costs, their data transfer, whether it's region to region, egress. A lot of people aren't really staying on top of that. And as soon as your spend is $500,000 a year, all of a sudden, it's a little late to start optimizing some of your traffic patterns. But so I'd say anytime someone's using Akamai, just run the numbers. I think you'll be happily surprised what you see with CloudFront.
And that's a great point. When you do run those numbers, I've never had somebody come back and say, oh, CloudFront is so much more expensive as compared to whoever else. A lot of it goes into how are the services built, how do you use them, and what the charges are for. I always recommend CloudFront to my customers, even if they're not even looking for the caching performance. I recommend it for the security that it adds. The performance is a bonus on top of that.
Yeah. And I certainly think logic running on the edge is very appealing. To what extent do you think AWS users are taking advantage of that? Is it more theory now, or have you seen practical applications out there being applied?
Now, I've actually seen more and more adoption of that. So I see customers using the Lambda at the edge in order to actually personalize content and deliver different content. For example, you might run Lambda at the edge to help determine, well, is my user coming in from the Tampa area or the Orlando area or the Jacksonville area, for example,
Right.
and make a decision to serve them a different version of your application or different pre-filled information. And I see that more and more commonly now, where they're making those decisions not on client side, the way they used to do that with JavaScript, but now I'm seeing it at the edge, making those decisions, and they can actually do a little more interesting things that way because they can rely on some more advanced logic, and they can reach out to databases to help feed that or external data sources, things you can't do on JavaScript.
Yeah. And so then so you're taking the load, which is obviously great, taking that load off of your back end systems. You're making that decision much more efficiently from a customer experience perspective. And it'd almost be interesting, I think, at some point for us to have a deeper dive into computing on the edge if people are interested.
Yeah, absolutely.
All right. Any other questions out there? I know someone's got one. Vince McCoy, I'll call you out. What kind of question do you have, Vince? And if no one has a question, that's fine. I just want to make sure this is interactive. All right. Well, with that, David, certainly appreciate that. Everyone will make this recording available. Unfortunately, my associates from or my sponsors from IO Associates aren't here, but we'll make this available. We'll announce this on LinkedIn. It'll be on their YouTube website. Thanks, everyone, for giving us an hour of your day. David, thank you. Hope to have you back again sometime, and hope everyone has a great day.
All right. Thank you, everybody. I appreciate the opportunity. Thank you for listening to me for 45 minutes or so. And I will be happy to come back. I'll work with Jeff and we'll see what topics or discussions are interesting for everybody. So thank you again.
All right. Terrific. Thanks, everybody. See everyone later.